now start our lesson of today called the linear function. Below we have some characteristics of linear function. The first characteristics of linear function is the form of a linear function is y, which is equal to mx plus c, where m and c are constants. Means that m is a coefficient of x and c is a constant. The second characteristics, a linear function on Cartesian plane always a straight line. Means that if you plot a linear function on Cartesian plane, always it becomes a straight line. The third characteristics, the constants can be 0 or other integers. Means that the constants, the values, it can be 0 or other integers. It can be positive or negative. The last one, the highest degree of linear function is 1. Means that the power of x, yes, the power of x is equal to 1. Means that those are any characteristics of a linear function. So here we have example. An example on a Cartesian plane represents the following linear function. Here we have a linear function y is equal to x plus 1. We ask to present on a Cartesian plane. So now let us present plane. Remember, a formula or a form of a linear function is equal to y is equal to mx plus c. So now the linear function you have y is equal to x plus 1. Means that you can m is equal to, it is equal to, and c is equal to 1. So now to present a linear function on a Cartesian plane, first of all you have to find the table of value. So now you have table of value x and y. So now you can find any coordinate you have. If you want -2, -1, 0, 1 and 2. Yes. Okay, now so now for the above equation, for the above linear function, so you have y which is equal to 2x plus 1. So now if x is equal to -2, yes, you substitute -2 by x and now get y is equal to 2 times -2 plus 1. So now we get 2 times -2, get -4 plus 1. -4 plus 1 we get -3. So now if x is equal to -2, y is equal to -3. So now if x is equal to -1, yes, you can take -1 times 2. Means that y is equal to 2 times -1 plus 1, which is 2 times -1 we get -2 plus 1, which is equal to -1. So now if x is equal to -1 and now y is equal to -1, so now if x is equal to 0, y is equal to 1. So now if x is equal to 1, we get y is equal to 2 times 1, which is equal to 2 plus 1, we get 3. So now if x is equal to, you replace x by 2, yes, x by 2, we get 2 times 2 is equal to 4. 4 plus 1 is equal to 5. So now here you have a table of value. Yes, the table of value so means that you have to draw by using a Cartesian plane or on a Cartesian plane. So this is x-axis. So now this one is the y-axis. So now you have a 1, you have a 2, you have a 3, you have a 4. So now you have 1, you have a 2, you have a 3, you have 4, and now you have 5. So and now you have a -1, -2, -3, and -4. So here you have -1, -2, and -3. So for drawing a Cartesian plane, first of all you have to use equal scale. So now here you have, if x is equal to -2, y is equal to -3. Yes, if x is equal to -1, y is equal to -1. If x is equal to 0, y is equal to 1. If x is equal to 1, y is equal to 3. And now if x is equal to y is equal to 5, means that, or this is a point, means that here we have point 2 and 5, point 1 is 3, 0, 2, 0, 1, -1, -1, -2, and -3. Means that by using this Cartesian plane we are going to present these points. Yes, this line x-axis shows the horizontal axis. Now this one it shows the vertical axis. This one is y. Yes, now let us draw. So now we have points. The first point, this one, we have a -2. -2 is here on x-axis, and the -3 on y-axis. This one. So this one is a point, the first point. The second point is if x is equal to -1 and y is equal to -1 for this point. So now if x is equal to 0, y is equal to 1 here. So now if x is equal to 0 here, y is equal to 1 here. So now if x is equal to 1 here, y is equal to 3. So now here we have a point. So now if x is equal to, y is equal to 5. So now, then after you have to join all points. Yes, you have to join all points. You have to draw a line which joining all points. This one, like this. Do you see here? This one. Means that immediately it gives a straight line. Yes. It has join all points. Draw a line which joining all points. This line is y, which is equal to x plus 1. Yes, this is a line produced by a linear function. The reason why we conclude that always a linear function is a straight line. So now, thank you students watching this video. If you liked, don't forget to click on subscribe, like, share, and comments. So now, goodbye. Hello friends, today we are going to learn how to calculate slope or gradients of a linear function. At the end of this lesson, everyone will be able to calculate slope or gradients of a linear function. For calculating gradients of a linear function, now let us consider the line passing through the following points. Consider the line passing through the points, means that you have 2 points. We have point A and point B. So now point A, it has 2 coordinates, x1 and y1. The second coordinate has the second point has 2 coordinates, x2 and y2. Means that you can plot point A and point B on Cartesian plane. Yes, this one. This is y-axis. The horizontal line is the x-axis. So now point A has the x1 and the x2, means that x1, x2, y1 and y2. Yes. Now you can join. You can draw a point of x1 and x2. This one is a point A, and the x2, yes, it has a coordinate of x2. This one, x2 to y2, means that you get x2 and y2. Means that for a slope, if you're going to find the slope or gradient, means that you have to join, or this one, to select any points you want, like this one. You can select one, you can plot like this one. Means that this one, from here up to here, this one is the change of y coordinates. From this point to this point, here you have the change of x coordinate, the x coordinate. So now if you're going to find the slope or gradient, means that you have to find the ratio of change y coordinates and the change of x coordinates. Means that the slope, it is calculated. Let us show you a formula used to calculate the slope. Means that slope, use a letter m, is equal to the change of y coordinate over the change of x coordinates, where the change of y coordinates is equal to y2 minus y1, and the change of x coordinates is equal to x2 minus x1. So and now m, it become what you call gradient or slope, is equal to y2 minus y1 over x2 minus x1. This is a formula used to calculate a gradient between two points. So now another things you have to know here, means that the slope, yes, the slope, it depends on the horizontal change. Yes, it depends on the horizontal axis. Means that this one is represent the x-axis. So now let us remove this one right here. This one, it becomes x3. So now if you find any points, yes, any points, now x, let us here get y3. Means that the slope, means that if you increase the horizontal axis, means that immediately slope increase, the slope increase. Yes. Now this is certain things you have to know here. You have to know a formula used to calculate the slope between two points, where we get y2 minus y1 over x2 minus x1. Means that y2 y2 minus y1 is the change of y coordinates, and the x2 minus x1 is a change of x coordinates. So now this is a formula used for calculating slope or gradients of a linear function. Here we have example. The following example: find the gradients of a line passing through the points. Means that we ask to find the slope of a line passing through the points 2, 5 and 3, 10. Yes. So now let us represent the above points on Cartesian plane. Yes. So now here let us take here we have a 2, and now here we have a 3. Yes. And now let us take here we have 5. Yes. And now here we have 10. Yes. This is y-axis. This is x-axis. So now 2 and 5, you have to plot point 1. The first point means that you have x1 is equal to 2, y1 is equal to 5, x2 is equal to 3, and the y2 is equal to 10. So now let us start for the first points. So now if x is equal to y is equal to 5, yes, you have to find the point. This one. So now if x is equal to 3, so now we get the point y is equal to 10, like this. Okay, so now we can join all points, these points. Yes. And now we ask to find the slope. Yes. So now for finding the slope, we have to draw a triangle like this. This is the change of y2 minus y1. So now this is the change of x2 minus x1. So now remember that we saw that slope is equal to y2, the change of y, minus y1 over change, let us clean this one, over the change of x, which is equal to x2 minus x1. So now what is y2? y2 is equal to 10 minus 5 over x2 is equal to 3 minus 2. So which is equal to 10 minus 5 we get 5, 3 minus 2 we get 1, and now the slope is equal to 5. Yes, m is equal to 5. This is how you can calculate the slope between two points. Means that for calculating slope is equal to the change in y over the change of x. So now we have any threads where you can use a slope. Means that you can use a slope for constructing loads in construction, where you have to construct loads. We need a slope to calculate slopes. If you are going to build a stairs, means that we need to know the slopes. So now if you want to build a house at any region, means that you have to know the slope. So now, my friends, this is the end of the lesson of today. Means that you have to watch this video if you like it, and now don't forget to click on subscribe, share, like, and write a comment. Bye bye. Hello. Welcome to my channel. Today we are going to learn how to find the equation of line given a gradient or slope and a point. So by the end of this lesson, runners will be able to find the equation of line given a gradient and the points of a line. So let us start the lesson of today. Find the equation of a straight line given the gradient and the point on the line. Means that here we are going to study how to find the equation of line where gradients and the point of a line are given. Here I have an example. A straight line with gradient 3 pass through the point A, 3 and negative 4. Find the equation of line. Means that here we ask to find the equation of line with the gradient 3 and the pass through the point 3 and the negative 4. So let us show you the formula used to find the equation of line. So now let us use equation of line. Y minus y0 is equal to m bracket x minus x0. So now this is a formula used to find the equation of line, where m is the gradient or where m is the slope. Means that m is the slope. Is the slope or gradient. So above equation of line means that we have m is equal to 3, where point A 3 and the negative 4. So now x0 is equal to 3, y0 is equal to negative 4. So now y minus y0 is equal to m bracket x minus x0. So now we have to replace y0 by its value, m by its value, and x0 by its value. Equation of line become y minus bracket minus 4, because y0 is equal to minus 4 is equal to m is equal to 3 bracket x minus x0 is equal to 3. Remove bracket for all term, we get y minus times minus 4, we get plus 4 is equal to 3 times x, we get 3x. 3 times minus 3, we get minus 9. So collecting like a term, y is equal to 3x minus 9 minus 4. Okay, so now y is equal to 3x minus 13. Means that this is the equation of line we ask to find. Here we have another example. Find the equation of line. Find the equation of a straight line which pass through points A 2, 5 and point B 3, 10. Means that here we have 2 points, and now we ask to find the equation of line. So now let us show you how to find the equation of line pass where we have 2 points. So now if you have 2 points, first of all you have to find the gradients pass through, gradients between 2 points. Yes, we have to find the gradient between 2 points. Then after finding the gradients between 2 points, and now then you find the equation of line. So now yesterday we saw how to find the gradients or slope. Means that here we have point A. Yes, it has 2 and 5. And the point B, 3 and 10. So now point A, you have x1 is equal to y1 is equal to 5. So point B, x2 is equal to 3 and y2 is equal to 10. So now you can find the gradients. M is equal to, gradient or slope is the change of y, y2 minus y1, yes, over x2 minus x1, which is equal to y2 is equal to 10 minus y1 is equal to 5 over x2 is 3 minus x1 is 2, which is equal to 10 minus 5 you get 5, 3 minus 2 you get 1, which is equal to 5. So now M is equal to 5. Remember equation of a line, the formula of equation of a line is y minus y0, which is equal to m brackets x minus x0. So now take point A. Yes, point A. Let us take point A. Means that point A. Yes, point A, 2 and 5. So now x0 from point A is equal to y0 from point A is equal to 5. So now you can find the equation of line, and the y minus y0 is equal to 5 is equal to what? M is equal to 5 bracket x minus 2. Remove bracket, we get y minus 5 is equal to 5 times x, we get 5x, and now 5 times 2 we get minus 10. Okay, so now collecting like term, we get y is equal to 5x minus 10 plus 5. Okay, so now y is equal to 5x minus 5. So now this is equation of line passing through point A and B. So now my friends, if you have 2 points, first of all you have to find a gradient. Yes, means that if you ask to find the equation of line passing through between 2 points, so now first of all you have to find the gradients or the slope between 2 points, and then after finding the slope or gradient between 2 points, and now you have to find the equation of line. Means that you have to select the first point. Yes, select the first point, and now gradient, and now you find the equation of line. So now thank you my friends watching this video. If you like it, so now don't forget to click subscribe, like, share and comment. Bye bye. Welcome friends. Today we are going to study intercepts of line. So here we have 2 types of intercepts. We have Y-intercept and X-intercepts. Remember that the equation of line is equal to y is equal to mx plus c. About Y-intercepts is where x, which if x is equal to 0. About the X-intercepts is where y is equal to 0. Okay, so now based on this equation of line, if x is equal to 0, y becomes y is equal to m times 0, yes, plus c. So now y is equal to m times 0, we get 0 plus c. Okay, so now y is equal to c. Means that the points about y-intercept, if x is equal to 0, y is equal to c, means that y is equal to any constant. So now about x-intercept is where y, means that here we have a y, equation of line is equal to m x plus c. Okay, so now if y is equal to 0, means that the equation of line becomes 0 is equal to mx plus c. Collecting the rectangle, get 0 minus c is equal to mx. Yes. Okay, so now m is equal to minus mx here is equal to minus c. So now x is equal to minus c over m. So now you have a point about x-intercept point, it becomes x minus c over m and 0. So now when you say intercepts, yes, let us take an example. Y is equal to 2x plus 4. Yes, 2x plus 4. This is equation of line. So now we have to find the y-intercept and x-intercept. Let us start on y-intercept. Yes, intercept. Intercept is where x is equal to 0. So now equation of line becomes y is equal to 0 plus 4, and then now y is 2 times 0, we get 0 plus 4. So y is equal, okay, so now y is equal to 4. So let us find the x-intercept. About the x-intercept means that we have a y which is equal to x plus 4. Remember that the x-intercept is where y is equal to 0. So now equation become 0 is equal to x plus 4. Collecting like a term, we get 0 minus 4 is equal to x. So 0 minus 4, we get minus 4 is equal to x. So now divide the 2 both sides. Here divided by 2, and now here divided by 2. Negative 4 divided by 2, get negative 2, which is equal to 2x over 2, we get x. So now here x is equal to minus 2. You can write the points of intercept, x-intercept. Point of x-intercept, x is equal to negative 2 if y is equal to 0. And now here I have to write the point of y-intercept. So now if x is equal to 0, y is equal to 4. So now you can draw a Cartesian plane. Let us draw a Cartesian plane, and now I show you x-intercept and y-intercept. So this is x-intercept, is the x-axis, I mean. This is y-axis. You have it 2, you have 4. So now here you have a negative 2, and there have a negative 4. and then now here we have a 2, and then now we have a 4. So about X intercept. X intercept is a point, is a point where equation of line passing through on X intercept. Yes, this one is what you call, means that if you draw equation of line, yes, the points where equation of line passing through on X axis is what you call X intercept. About Y intercept is a point, is any point where equation of line passing through. So now here we have any points. Yes, you have points here. Yes, you have points. You can draw points 0 and 4. Yes, 0 0. If X is equal to 0, here we have a 0 0, where X is equal to 0 and Y is equal to 0. So now if X is equal to 0, Y is equal to 4, means that here we have a point. So now this is X is Y intercept. Yes, is Y intercept. Yes, the Y intercept. About the X intercept, if X is equal to negative 2, yes, if X is equal to negative 2, Y is equal to 0. Means that if Y is equal to 0 here, X is equal to negative 2. Now you can draw a line. Yes, this one. If X is equal to 0, Y is equal to 4. Means that here we have a point. So now if X is equal to negative 2, Y is equal to 0, means that this one here we have another point. So now you can draw a line joining those 2 points. Yes, like this. Yes. So now this is Y, which is equal to 2x plus 4. Means that the equation of line, yes, the equation of line it pass through this one. This is a Y axis, Y intercept. Yes, at 0 and 4, at point at the values of 4. This one is a point, is X intercept. This one is the X intercept. Yes, means that the intercept of a line, means that the Y intercept, means that the equation of line it pass through, or it pass through this one 4 at, means that it take place at the values of 4. On X axis it take the points, it is located on negative 2. Means that these points, negative 2 is the X intercept and the 4 is the Y intercept. So now essential things you have to know here. You have to know how to calculate the intercepts of a line. First of all, you have to calculate Y intercept where X is equal to 0. Means that if X is equal to 0, yes, means that you get these points. Yes, means that you get Y, which is equal to C. So now about the X intercept is where Y is equal to Z is equal to 0. Means that the X intercept is a point. Yes, is a point which equation of line intersect on X axis, while Y intercept is a point where the value intersects on Y axis. So now thank you for watching this video of how to calculate the intercept of line, where we learn how to calculate Y intercepts and the X intercepts. Thank you for watching this video. If you like it, so don't forget to click on subscribe, like, share and write comments. Bye bye. Hello friends, welcome again on my YouTube channel. I'm teacher Valens. Today we are going to study how to solve a simultaneous equation by using elimination methods. So here we have an example. Solve a simultaneous equation by using elimination methods. Yes, means that this is a simultaneous equation. Remember that a simultaneous equation, those are the equation with 2 or more variables. Means that 3x minus 2y is equal to 8. and x plus 5y is equal to negative 3, we ask to solve the simultaneous equation by using elimination methods. Okay, so now by using here you have to think a number, any number. You can eliminate the terms of x, or you can eliminate the terms of y. So now let us eliminate the term of the term of x. So now here you have this one is equation 1, this is equation 2. Yes. So and now you can think a possible value, because we are going to eliminate the terms of the term of x. Yes. And now you can think the possible value used to eliminate the values of x, means that here you can multiply by 1, and now here you can multiply by negative 3. So now 1 and the negative 3 multiply each term. Yes, on simultaneous equation. Now we get 1 times 3x, we get 3x. 1 times negative 2y, we get negative 2y is equal to 1 times 8 is equal to 8. For the second equation, negative 3 times x, we get negative 3x. Negative 3 times 5y, we get negative 15y is equal to negative 3 times negative 3, we get 9. And now we have to make addition. 3x minus 3x, this one it gives 0. And now we get negative 2y, negative 15y, we get negative 17y, which is equal to 8 plus 9, we get 17. Okay, so now find the values of y. Y is equal to 17 divided by negative 17. Okay, so now y is equal to 17 divided by negative 17 is equal to negative 1. So now this is a values of y, is a values of y. Okay, so now let us take this one, the values of y, as the equation 3. Yes, now you can substitute, or you can replace y in equation 1. It means that 3 in equation 1 means that you have 3x minus 2, replace y by negative 1, get multiplied by negative 1 is equal to 8. So now 3x minus 2 times minus 1, we get plus 2 is equal to 8. So now 3, collecting like term, 3x is equal to 8 minus 2. 3x is equal to 6. Now x, it become 6 over 3. So now x, 6 over 3 is equal to. So now the possible solution, or the possible value which can make the following simultaneous equation become true is equal to where the values of x is equal to and the values of y is equal to negative 1. It means that this is a possible value which can make this simultaneous equation become true. So now, if my friends, if you like this video, don't forget to click on subscribe. Thank you. Bye bye. Hello friends, today we are going to learn perpendicular lines. So by the end of this lesson, learners will be able to verify two lines are perpendicular. Consider two lines. Line 1, y is equal to m1 x plus c1, and line 2, y is equal to m2 x plus 2c plus c2. Lines are said to be perpendicular if the product of their gradients gives -1. It means that m1, yes, m1 is the gradient of the first line, times m2 is a gradient of the second line, which is equal to -1. Means that if the product, yes, if the product of the first line times the second line is equal to -1, we conclude that two lines are perpendicular. So let us use a Cartesian plane. You have x-axis, and now here we have y-axis. Let us draw any line. This is a line 1. Yes. So now a line 2 is perpendicular to line 1, like this. This is a line 2. Means that a line 1, it is perpendicular to line 2, or line 2, it is perpendicular to line 1. So a perpendicular line means that a line 2, it passes through line 1. Means that here we have an intersect, we have any points. We have any points which intersect line 1. This one, this point, yes. Means that this one is line 1. Now a line 2, it passes through line 1. It passes through line 1. Means that a line 1 and the line 2, you have any point which intersect two lines. Means that you conclude that two lines are perpendicular. Okay, so now if you have m1 times m2 is equal to -1, you can find the m2. Yes, m2 means that m2 is equal to m2 gradients of the second equation. m2 is equal to -1 over m1. So now essential things you have to know here. You have to know that two lines are perpendicular if the product of their gradients is equal to -1. Means that if the product, if you take gradient 1 times gradient 2, means that the gradient 1 is the gradients of the first lines times m2 is the gradients of the second line, which is equal to -1. We concluded that the lines are perpendicular, or the lines are orthogonal. Here we have an example. Find the equation of line through 5, 2, which is perpendicular to the lines 5y minus 2x is equal to 10. Means that we ask to find the other equation of line which pass through points 5 and 2. Means that it become perpendicular to line 5y minus 2x, which is equal to 10. So now the solution, it become, we have a 5y minus 2x is equal to 10. So the form of equation of line is equal to m x plus c. So now 5y is equal to 2x plus 10, and now y is equal to 2x plus 10 over 5, and now y is equal to 2 over 5x plus 2. This is equation of line 1. Means that if this one is the equation of line 1, yes, means that m1, their gradient is equal to 2/5. Remember that two lines are perpendicular if m1 times m2 is equal to negative 1. So now replace m1 by 2/5. Yes, replace m2 means that you get 2/5 m2 is equal to negative 1. You can make cross product, so and now get 2m2 which is equal to minus 1 times 5. It gives 2m2 is equal to negative 5, and now m2 is equal to minus 5/2. This is a gradient of the second equation of line. So now here you have a point. We have a point 2 and 5. So now remember that m gradient is equal to y minus y0 over x minus x0. So now here we have y0 is equal to 2, x0 is equal to 5, where m is equal to negative 5/2. So now you can, based on this data, you can find the equation of line. Means that m is equal to negative 5/2, which is equal to y minus 2 over x minus 5. So now we can make cross product. So now we get minus 5 bracket x minus 5, yes, is equal to 2 bracket y minus 2. So bracket means is multiplication. So now remove bracket, we get minus 5x minus 5 times minus 5, we get plus 25, which is equal 2 times y, you get 2y. So 2 times negative 2, we get minus 4. So now collecting like a term, so now y, we get y is equal to minus 5x is 2y, is 2y. So minus 5 plus 25 plus 4. So now 2y is equal to negative 5x plus 25 plus 4, we get 29. Okay, so now equation become y is equal to negative 5x plus 29 over 2. Okay, so now y is equal to negative 5x over 2 plus 29 over 2. So now this is a second equation. This is the equation we asked to find, which is perpendicular to the following equation. It means that y, which is equal to negative 5 over 2x plus 29 over 2 is perpendicular to 5y minus 2x, which is equal to 10, or y, which is equal to 2 over 5x plus 2. So now we are going to verify two equations are perpendicular. So now let us take this equation. For this one, for this equation, yes, you can find the y-intercept. Y-intercept, yes. So y-intercept, so the point is 0 and 29 over 2. This is the points. So about the x-intercept, so means that where x means that about the x-intercept we get 5.8 and 0, where y is equal to 0. For the second equation, we will have y is equal to 2 over 5x, yes, plus 2, yes, plus 2, means that y-intercept the points of y-intercept where x is equal to 0, y is equal to. Okay, so now about the x-intercept, yes, about the x-intercept, so now y-intercept, x-intercept, so now here we get negative 25 because y is equal to 0. So now you can plot the above points on a Cartesian plane, yes. So now this is x-axis, so this is y-axis. So the first point here we have let us take 5.8 letters here, 5.8. Another point you have 29, let us take here, it is here, 29 over 2. Another point you have 0 and 2, it is here, yes, here you have 2. Another point you have negative 25. Let us put negative 25 here. So you can plot a point, yes, this point, this one means that here we have point 0 and 29 over 2. Here we have 0 and y is equal to 29 over 2. Another point here we have 5.8 where y is equal to 0 is here. So now you can draw a line, this one, joining this point like this. This one it becomes line 1, yes, let us becomes line 1. So and now another point of line here we have 0 and 2. If x is equal to 0, y is equal to. So now another point, if x is equal to negative 25 here, y is equal to 0, means that here we have a point. You can join these points and this one, and now we get a line. So now let us draw. This one is a line. This is a line 1, and now this is another line. Let's clean this one. This one is a point, another point. So now this is a line 2. So do you see here, a line 1 is perpendicular to line 2, or line 2 it is perpendicular, means that line 2 it pass through line 1. Yes, line 2 means 1, this is 1 is line 1, and now line 2 it pass through, or it is perpendicular to line 1, means that you conclude that two lines are perpendicular because each line it pass through others. So now thank you students watching this video. If you like it, don't forget to click on subscribe and like, share and write a comment. So bye bye. Hello friends, the lesson of today is the parallel line. By the end of this lesson, the learner will be able to verify two lines are parallel. Rule you have to know here: lines are parallel if they have the same gradients. Yes, means that if two lines have the same gradients, means that you conclude that two lines are parallel. Consider two lines. The first line is y is equal to m1x plus c1, where m1 is a gradient of the first lines, and y2 is equal to m2x plus c2, means that m2 is the gradient of the second line, where c1 is a constant value of line 1 and c2 is a constant value of line 2. Now if gradients or slope of line 1 is equal to slope or gradient of line 2, means that you conclude that line 1 and line 2 are parallel. Yes, if the slope of line 1 is equal to the slope of the second line, you conclude that those lines are parallel. So now let us take an example here. So compare the following equation of line. Here you have y is equal to x plus 4. So another example, y is 2y is equal to 4x minus 6. So now this is A, example A. About the example B, so y is equal to x plus 4. So y is equal to 2x minus 5. So now compare the following example. Yes, verify two lines are parallel. Yes, about the question A. Yes, so y is equal to 2x plus 4. This is equation 1, or is line 1, where the gradients m1 is equal to the gradients of the first equation is equal to. About the second lines, we have 2y is equal to 4x minus 6. So now y is equal to 4x minus 6 over 2. So y is equal to 2x minus 6. And now the gradients of the second line is equal to. So about the second example, so now the gradients of equation 1 is equal to 1, because here we have the coefficients of 1. So now about the gradients of the second equation of line is equal to. So now for the first example, yes, for the first example, for example A, m1 is equal to m2. So now while for the second example, m1 is different to m2. And now you conclude that A equation of line, yes, lines A are parallel because M1 is equal to M2, while equation on about the second example, equation 1 is not parallel to equation 2 because M1 is different to M2. Here we have example. Find the equation of line which pass through the points 2, 1 and is parallel to 2y is equal to 2 minus 6x. Means that we ask to find the other equation of line which pass through point 2, 1 and now it is parallel to equation 2y which is equal to minus 6x. So now let us find the equation of line. So now here we have the equation of line. We have a 2y which is equal to minus 6x. Remember, equation of line, it is written as y which is equal to mx plus c. So now change the equation of line, we get y is equal to minus 6x plus 2 divided by 2. So now y is equal to minus 3x plus 1. This is the equation of line. So now the gradients m1 is equal to negative 3 because the negative 3 is a coefficient of x. So now remember that two lines are parallel if and only if m1 is equal to m2. So remember that m1 is equal to negative 3 means that negative 3 is equal to m2, means that the second gradient, the m2 is equal to negative 3. So now if the gradients of the second equation is equal to negative 3, means that we are going to find the equation of line passing through point of 2 and 1, yes, means that with the gradient of negative 3 we are going to find the other equation of line, yes, the other equation of line passing through points 2 and 1, yes, which is parallel to with the gradient of negative 3, means that remember that the equation of lines y minus y0 is equal to m bracket x minus x0. So now y means that where x0 is equal to and y0 is equal to 1. So now replace each term by its value. Y minus y0 is equal to 1 is equal to m is equal to negative 3 bracket x minus x0 is equal to. Okay, so now y minus 1 removing bracket is equal to minus 3 times x minus 3 x minus 3 times minus we get plus 6. Okay, so now y correcting like term is equal to minus 3x plus 6 plus 1. So now y it become y is equal to negative 3x 6 plus 1 plus 7. So now this is the second equation of line, yes, means that you conclude that equation of line y1, the first equation is equal to negative 3x plus 1, yes, is parallel to the second equation y, which is equal to negative 3x plus 7. So, and now here means that m1 is equal to negative 3, while m2 is equal to negative 3, means that m1 is equal to m2, means that you conclude that two equations of line are parallel. So now, thank you students for watching this video. If you like it, don't forget to click on subscribe, like, share and comments. Bye bye.